Hi there, it's Becca here from the Northeast Autism Society, and today we are joined by Tony and Danny from the Life Science Centre Newcastle. And what are we going to be doing today?
Well, today we are thinking about rocks and about acid, because quite a few of the young people asked us to do a video about acids and erosion and things like that. We know that acids can wear down rocks, dissolve them a bit. For example, you get a lot of caves in areas with a lot of limestone where the water is slightly acidic, and over thousands and thousands of years it's dissolved that rock and made a nice cave. We don't have thousands of years, so we're gonna do something a little bit faster. We're gonna do an experiment using vinegar as our acid and chalk as our rock.
That's interesting, because I always think, when you think acids, you sometimes think, are they something scary and something I shouldn't touch? Are they dangerous?
Well, exactly. There are acids that are dangerous and that you wouldn't want to touch, but vinegar is also an acid, and it's weaker than the very strong acids, but it's also stronger than the water that's eroding the caves over thousands and thousands of years. So it's all a little bit of a scale of how strong they are. When we're doing an experiment, we want to have a question in mind. So for this experiment, I thought we could ask the question, will the size of the rock affect how quickly the acid breaks it down? To start, I've got two pieces of chalk that are the same size. I'm going to put one into a pot, and I'm just going to leave that one whole. I'm going to take another one, and I'm going to break it up between two spoons. So it's on one spoon there, and I'm just going to slowly crush it up and make it into a powder. And this means there are more surfaces for the acid to react with, and we call this giving it a higher surface area. So just nice and gently rubbing it together, and tilt that slightly. You can see it's all crushed up. I'm going to put that in to a second tub. Another thing to consider when you're doing an experiment is making it a fair test. So do you two have any suggestions about what we can do to make this a fair test?
If we use the same amount of chalk.
That's a good one, yeah. So we had those two bits and they were pretty much the same size.
Yeah.
That's definitely a good start.
I guess another thing we'd want to keep the same is the amount of vinegar we put into each dish, so we have the same amount of vinegar.
That's a good thought. So
what about sort of time limits? Are they both going to be in there the same amount of time?
That's another good question. Yeah, you don't want to set off one and then set off another 10 minutes later, but then check on them at the same time, because one's had a lot longer to react. Okay, let's think about the vinegar then. So how much vinegar do you think we should add? Do you think we should do like a few drops? Do you think we should fill a tub? What do you think is a good idea?
I definitely think we should cover the whole of the bottom of the pot.
Yeah, maybe enough to cover the chalk so that it's covered on all surfaces, so there's none sticking up at the top.
Yeah,
I think that's a good idea.
So Danny, does it matter if we use brown vinegar or white vinegar?
It shouldn't. Most vinegar is the same strength, the same kind of amount of acidity, so the reaction should work the same. This just happens to be the one that I have in. Okay. So they've both got roughly, I didn't measure it, but holding them side by side, they've got roughly the same amount of vinegar in, and it's covering up the chalk. And now we observe what's happening. So, if we go for the big one, the whole block, it's slowly putting out little bubbles. There's little streams of bubbles are coming off it.
Oh yes, I can see those. It's very cool.
Oh, they're very tiny, but yes, they're bubbles, definitely. And so how can we get bubbles? Because I think bubbles they've got a gas inside them, but what we've started off here with is a liquid, the vinegar, and a solid, the chalk, but now we're getting a gas.
Good question. The chalk is made of calcium carbonate, and it reacts with the vinegar, with the acidic parts of the vinegar, and that carbonate turns into carbon dioxide. And so carbon dioxide gas is being made, and that's what's bubbling up through the vinegar as the reaction happens. And actually, if you put your ear to the pot, I can hear this one is fizzing a little bit, and let's have a look at the one where it was all broken up. Again, we've got a lot of bubbles being made, and oh, this one's fizzing even louder. So we're not just investigating by looking, we can hear.
Yeah, we're using a couple of different sensors here, aren't we?
So how long will we have to wait for the experiment to kind of finish, for the reaction to finish?
That is a very good question. And in some senses, it's kind of up to you. You could say, I'm going to leave it for 2 minutes. You could say, I'm going to leave it for 10 minutes. You could leave it for even longer. I set some up about half an hour ago. Let's have a look at what they're doing. So they've had just a little bit more time than these ones. So this is our full lump, and I'm going to take the chalk out and hold it up to the camera, and you can see it's not a straight lump of chalk anymore. There's kind of bits missing, chunks that have looks like they've fallen off or broken away.
It's a bit worn away now, isn't it?
Yeah, and if you look in the tub itself, there's kind of a little collection of white stuff, a kind of sediment, or kind of like a powder almost, and that's the it's called calcium acetate, and it's where the acid has reacted with the chalk, and it's made carbon dioxide, which is bubbled up. It's made a little bit of water as well, and it's also made this chemical calcium acetate, which looks kind of powdery, and it's just sitting at the bottom of that pot. And so there's a little bit.
That's one of the ways we know that a chemical reaction is taking place, is we get new things formed. So we've got the carbon dioxide bubbles and also this white powder that's at the bottom, the calcium acetate.
Exactly. And if we look at the other one, the one where it was broken up, there's actually a whole lot more of the calcium acetate. The whole bottom of the pot is covered in it to an extent. So as I'm turning it and switching the vinegar around, you can see it's all in a thin layer all across the bottom. So it seems like more has been produced in the broken up chalk pot. So that would suggest to us that more of a reaction has happened where the chalk has been broken up compared to the one where it was left whole.
Yeah. And I'm just thinking, if we used white vinegar, do you think we could add some food colouring in just to make the bubbles a bit more visible? Would that work?
I definitely think it's worth a try. Yeah. As you say, it wouldn't really work with my brown vinegar, but if you had white vinegar, I'd say add a few drops, see what happens.
Yeah.
We encourage people to try this experiment at home. So if you want to add your own spin, maybe you want to try adding food colouring, or maybe do one whole bit of chalk, one that's broken up a little bit, and one that's broken up a lot, or add your own.
Changing the size.
And make predictions about what you think is going to happen in each case, and then see if your prediction comes true or not in the end.
Great. Sounds brilliant. I think our young people will really enjoy this one.
No, definitely. It's a lot of fun, and it's nice listening to all the bubbles and things like that.
Yeah. Well, thank you very much, Danny and Tony, for showing us that. And don't forget, if you're watching us at home, to let us know how you get on with this experiment. We'd love to see your photos and videos. And we'll see you next week. Thanks. Bye.
Bye.